Hey guys, this is video 7, tangent lines and approximations. So whenever you see write an equation of a tangent line, you should immediately think x value, y value, slope, derivative at the x value given. So slope is just derivative, that's all we need to remember. So we need to know the equation, which I know you are all very good at. Y minus y1 equals m times x minus x1. And you're going to plug in that y value. The slope is your derivative at that x value, and your x1. Okay, so you could see this question as a basic derivative, write the equation of a tangent line. You could see it using implicit differentiation, and then write the equation of the tangent line. You could see it make a tangent line and then use it to approximate a value. So if you need to approximate the value, you just have to substitute the value in to find the approximation. So let's do an example here. Determine the equation of the tangent line. Right away you're thinking x, y, slope to the curve with the equation that. So I have x cubed plus 2xy plus y cubed equals 13 at the point 1, 2. So I'm going to take the derivative of this. So I have the derivative of x cubed is 3x squared. Then I have plus 2xy. Now the 2xy is a product rule, and it's going to now I need to use implicit, right? Because x and y, I can't take the derivative of both of them at the same time. So I'm taking the derivative with respect to x. So I'm going to do my first d second plus second d first for my product rule. The first is 2x. Derivative of the second. So the second one is y. If I take the derivative of y, it's just 1. But I'm taking it with respect to x, so it's dy dx. Plus second, which is just y, d first, the derivative of 2x is just 2. And then let's finish this out. So we have plus 3y squared, so that's 3y squared dy dx, because dy dx is going to be my, with respect to x, equals 0. Okay, so if you think back to the implicit video, remember, we're going to circle everything that has a dy dx with it, and I'm going to put all those on one side, and everything else on the other side. So I'm going to do some algebra to switch things over, like I would subtract 3x squared and subtract 2y. I'm going to put the 2x plus 3y squared, 2x dy dx plus 3y squared dy dx is equal to, this is going to be that negative 3x squared minus 2y. Okay, so now remember we factor out that dy dx. So dy dx goes on the outside. And we have left over 2x plus 3y squared equals negative 3x squared minus 2y. And I just have to solve for dy dx, so I'm going to divide both sides by that 2x squared, which I'm running out of room, plus 3y squared. Oops, I think I made that a squared. Not a squared there. So 2x plus 3y squared. Alright, so I'm going to write this over on another page. So what was the point of this, right? We're finding the equation of the tangent line. Why did I take the derivative? Well, because I need the slope, right? I have the point. The point was 1, 2. So all I'm missing is the derivative, which is just going to be the slope. And here I have my x and y that I can plug into. So my dy dx is equal to negative 3. Plug in the x first. So we have 1 squared minus 2. Here's your y times 2 over 2 times 1 plus 3, 2 squared. So we have negative 3 times 1 is negative 3 minus 4 over 2 plus 2 squared is 4 times 3 is 12. So we have negative 7 over 14, which is just negative 1/2. So my slope is negative 1/2. I have my x and y. Time to write my equation. Y minus y1 equals m times x minus x1. So y minus 2 is equal to negative 1/2 times x minus 1. And that's my equation of the tangent line. Now don't simplify it unless you need to. Right now I'm good. Leave that alone. Unless you need to simplify it, like when we're going to approximate, or it tells you to, you can leave it just the way it is. If your part B to that question is using your tangent line from above, approximate a value, that f of 1.1, I'm using my tangent line to approximate 1.1. So I'm just going to take my x value and plug in 1.1. So I still have y minus 2 is equal to negative 1/2 times 1.1 minus 1. 1.1 minus 1 is 0.1, or you could think of it in terms of fractions, which might be a little easier for this one. 1/10 equals y minus 2. I'm just solving for y, so multiplying those fractions across, we have y minus 2 is equal to negative 1 over 20, plus 2 on both sides. Now remember, I'm adding fractions, so that 2, I want to turn it into something with a denominator of 20, so which will be 40 over 20, because 40 divided by 20 is 2. So you have negative 1 over 20 plus 40 over 20 gives me 39 over 20, which is equal to y. So y is the same as saying f of 1.1 is approximately 39/20. Okay, so approximating, we just take that value and we substitute in for x. Sometimes it's easier to change it to a fraction like I did here. Sometimes not. I mean, if this was not a fraction in front, this negative 1/2, I probably would have just said 1.1 minus 1 is 0.1. Multiply it by the number in front, like 2, it would just become 0.2. So usually they're a little simpler than that. I just gave you a little tougher one because I wanted you to get more practice with those fractions. Alright, so when you approximate, you may also be asked if it's an underestimate or an overestimate. When you're approximating with underestimate or overestimate, you should immediately think the second derivative. Okay, so underestimate, overestimate, think the second derivative. If the second derivative is positive, well, what does that mean for the curve? Second derivative is positive means it's concave up, right? So if I draw a concave up function, where is the tangent line? The tangent line has to be below the graph. It should touch at one point there. And if I'm going to approximate a point using that tangent line, so say I'm approximating that point using the tangent line, this is always going to be an underestimate because the tangent line is under it. If the second derivative is negative, that means it's going to be concave down, right? Which means your tangent line has to be above your function. So this is an overestimate. Okay, so when you have to underestimate, overestimate, lower approximation, upper approximation, you need to think second derivative. What's the concavity of the function? Is it positive? Is it negative? And then you'll be able to decide, okay, that tangent line is below the curve or the tangent line is above the curve, and underestimate or overestimate.